Today I am starting the question answer of the chapter pressure, and I think this is very helpful to the student who are preparing for the examination. Okay, let's have the question. First question, what is pressure? Write down is SI unit. Now pressure can be defined this way: force acting perpendicular to unit area of a surface is called pressure. Here we have two matter. One is force, another is area, and force acting on unit area is pressure, and SI unit is Pascal. In the name of the scientist Pascal, the unit is taken Pascal. Okay, let's have a detailed look about the definition. This is, let's say, unit area 1 meter length, 1 meter breadth. If force is not acting perpendicular, if force is acting this way, then we cannot say that this force divided by unit area is the pressure acting on this surface. But instead of this, if the perpendicular force acts on this unit area, then it is considered as pressure, and it can be calculated by using this equation: pressure P is equal to force by area. Okay, now let's have another question. What is 1 Pascal pressure? 1 Pascal means pressure exerted by 1 Newton force on or 1 meter square surface area is called 1 Pascal pressure, and mathematically it can be represented this way: 1 Pascal equal to 1 Newton upon 1 meter square. Okay, let's have another question, and this is numerical problem. Calculate the pressure exerted by the given solid body of weight 50 Newton having length, breadth and height 3 meter, 2 meter and 1 meter respectively on the surface of contact in each case. The given is case 1 and case 2. In case 1, the body is lying length and breadth wise, and in case 2, the body is lying breadth and thickness wise. This is the question. It means force exerted by the body through the surface of contact is same, that is 50 Newton. Another quantity we need area, and pressure equal to force by area. We'll use that equation. So area in first case is L into B because the body is lying length and breadth wise, that's why area of contact is L into B. And in second case, area is B into S because the body is lying breadth and thickness wise, and so we are using different formula for area. And now I want to put the value: length 3 meter, breadth 2 meter, breadth 2 meter, height 1 meter. Now multiplying this, we get 6 meter square in first case, in second case 2 meter square. Now pressure equal to what in both the cases? Now we are using equation of pressure equal to force by area, and in place of force I am writing here 50 Newton, here also 50 Newton, but area is different. Here 6 meter square, here 2 meter square. 50 divided by 6 gives 8.33 Pascal. Newton per meter square is Pascal, and here 50 divided by 2 is 25 Pascal. This is the solution. This numerical problem gives an idea about the relation between force and area. If the same force is acting through large surface area, then pressure will be less. Here it is 8.33. If the same weight force is acting through less surface area, then pressure will be high, that is 25 Pascal in this case. Okay. Now let's have another numerical also. Compare the pressure exerted by a needle tip with 0.1 millimeter square area applied with 4 Newton force. Force and area is given. With a nail tip of 0.5 centimeter square area applied with 20 Newton force. Write conclusion with calculation. Looking at this numerical, just imagine that we have a needle and its tip has very less surface area, but we are comparing the needle with the nail, and its tip has more surface area than that of the tip of needle. So certainly area is less, it will create more pressure. Let's have the numerical. In first case, pressure of needle. What are the information? Force is given 4 Newton, area is given 0.1 millimeter square. This is the turning point. 0.1 millimeter square. We cannot use millimeter square because Newton per meter square is Pascal, and we are using that SI system. So millimeter square has to be converted to meter square. First, I want to convert it into centimeter square. Millimeter can be converted to centimeter by dividing with 10. 1 of the millimeter can be converted to centimeter by dividing with 1 of the 10, and another millimeter can be converted to centimeter by dividing with another 10. That's why I'm dividing 0.1 by 10 two times, and it converts to centimeter square. Now centimeter square has to be converted to meter square. 10 into 10 means 10 square. Now 1 of the centimeter can be converted into meter by dividing with 100. Another centimeter can be converted into meter by dividing with another 100. And 100 into 100 means 10 to the power 4. That's why we have 10 to the power 4 here. Then centimeter square converts to meter square. In denominator, we have 10 square into 10 to the power 4. It means 10 to the power 6. Power can be added if same base. Now 10 to the power 6 is if taken to numerator, then it will be 10 to the power minus 6. If this point is shifted towards right hand side, one digit right hand side, then this number should be multiplied with 10 to the power minus 1. We are taught in the chapter force and motion also. So I am multiplying this 0.1 with 10 to the power minus 1. But if it was shifted to left hand side, then we'll multiply the same number with 10 to the power positive 1. But at this time we are shifting towards right hand side one digit, that's why multiplying by 10 to the power minus 1. 10 to the power minus 1 into 10 to the power minus 6 gives 10 to the power minus 7. This is the area of the tip of the needle according to the given information. We are calculating pressure once with needle, another time with this nail. That's why I am using P1 and P2 here. P1 equal to force by area. Force is 4 Newton, area is 10 to the power minus 7 meter square, and if this 10 to the power minus 7 is taken to numerator, we will have 10 to the power 7. That's why final result is 4 into 10 to the power 7 Pascal. Newton per meter square is Pascal. 10 to the power 7 means 1 having 7 0, and when this number multiplies 4, then we'll have 4 having 7 0. This is 4 crore Pascal. This use pressure is created by the tip of the needle. Now let's have another pressure of nail. Force is 20 Newton, here it is given 20 Newton, and area is different, 0.5 centimeter square. Now we have to convert centimeter square into meter square. How? 1 of the centimeter can be converted into meter by dividing this number with 100. Another centimeter can be converted by dividing with another 100. That's why I am dividing 0.5 by 100 twice, and it comes in meter square. Now 100 into 100 is 10 to the power 4, 1 having 4 0, and when it goes up it gives minus 4. 10 to the power 4 becomes 10 to the power minus 4, and this point I want to shift it to right hand side, one digit right hand side. If we shift point to one digit right hand side, then the number should be multiplied by 10 to the power minus 1. If it was shifted to left hand side, then the number should be multiplied by 10 to the power plus 1, but we are shifting towards right hand side one digit, that's why 10 to the power minus 1. Now 5 into 10 to the power minus 1 into 10 to the power minus 4 gives 10 to the power minus 5 meter square. Now let's have the formula. Pressure P2 equal to F by A, and force is 20 Newton, area is 5 into 10 to the power minus 5 meter square. And if this 10 to the power minus 5 goes up, it becomes 10 to the power plus 5. And 20 divided by 5 gives 4 into 10 to the power 5 meter square, and it can be written as normal number like this, 4 having 50. It means 4 lakh. It is very less in comparison with the tip of the needle. That's why we can write one sentence. Therefore, pressure exerted by the needle is greater than the pressure exerted by the nail. Now let's have another. This is very important. State Pascal's law. What it is? According to Pascal's law, pressure exerted at any point in a confined liquid means the liquid is kept in a closed container, transmits equally and perpendicular to all the directions. Okay, pressure exerted at any point in a confined liquid transmits equally and perpendicular to all the direction. We'll have better idea in another question. I'll explain also. Verify Pascal's law experimentally. If it is asked in the examination, then you have to go through a diagram like this. This is a spherical glass vessel. It has 4 openings lying opposite to each other, and they are named as M and OP and piston is fitted with each of them. Each of the piston has same surface area and it is filled with water. If we press piston M, then it exerts pressure in this confined liquid, and what is found? All other piston is found to be pushed away from their original position, and P is pushed away, N is pushed away, O is also pushed away, but they are pushed to the same distance. If N is pushed to 1 centimeter, P is also pushed to same 1 centimeter, O is also pushed to same 1 centimeter. What it means? They are receiving equal pressure. The pressure transmitted to N, P, O is equal. So we can write this way: as shown in the diagram, a spherical vessel is completely filled with water and is fitted with 4 pistons M and OP of equal diameter. Each of the piston has equal diameter. If a force is applied on one of the piston, let's say M, all other piston is found to be moved away by the same distance. It proves Pascal's law, which says that pressure exerted at any point in a confined liquid transmits equally and perpendicular to all the directions. Okay, today I presented 6 questions and its answer. Now I want to stop. We'll continue in another class.